Fred Brown once again joins us, our epidemiologist. Like the
Um,
Merck withdrawing its candidate because Merck said it wasn't effective enough or something like that?
yeah, yeah. So, this is typical. This is much more typical than what we usually see in drug development, which is, half, a great majority of the candidates actually fail. And I had sort of predicted that half of them that are currently being evaluated in a later stage would fail, but I was kind of surprised and pleasantly surprised that we didn't have that many failures. And so I was saying, wow, this could be really great. And Merck, as you know, was expected to come onto market probably around May, June timeframe with some interesting vaccines that actually reproduce themselves in the body. These were antigens that reproduce themselves. So they use this for Ebola, which with great success to control Ebola. And uh, unfortunately, they had two candidates. One was a more traditional candidate. One was this new candidate, this new technology. And they went into phase one data. And I want to talk a little about phase one data today. They haven't released all the numbers at all, but we can take a look at what they were evaluating. And then they decided based on that, they weren't going to go forward.
Okay.
And some of the phase one data is sort of interesting. That relates to another issue that we talked about last time, and that was that we were finding that there was resistance on the new South African variants of the vaccine and of monoclonal antibodies, as well as of some of the even testings that we're doing for the spike protein. And so I was going to show you a little bit of that and why it's significant. And today, Moderna announced three big things. The first thing was that there's a six-fold reduction in our ability to control the new variant from South Africa with our traditional vaccines. However, that's not to say that a six-fold reduction isn't still going to give you good effectiveness. It still probably will, but they are nervous enough about it that they announced two new things, and that was they're going to start testing booster sequences. They're particularly concerned, as you know, about the elderly population, and they're also going to test a brand new vaccine specifically for this variant. And that was announced by the CEO this morning. And then they released just a couple hours ago. I'm still going through the data, but I thought maybe we can go through it together quickly, which is what the results showed. So I think it's the first indication from someone who really is interested in keeping this new vaccine on the market, unchanged for as long as possible, saying, we've got a platform that allows us to fairly quickly take things in and out. And so we may want to actually change our antigen. And this may be the indications that we're going to have more a flu type of vaccine than a measles type vaccine. A flu type of vaccine, as you know, you have to take only once, but every year, every season. And we might unfortunately see that happening with COVID now. And Pfizer is trying to do a joint flu and COVID vaccine. And Moderna is trying to do a straight up booster of their traditional vaccine and a new vaccine. So there's some indication by guys who really know a lot what they're doing that we may not have the full answer yet. We're getting there, but they're nervous, and I think rightfully so. Let me let's see if I can find a little bit of the data that I was looking at this morning, if that would be helpful, and we can kind of go through it and see what you guys think. Let's see here. So I think I showed you this last time, and that was about the new variant. I'm just going to the slideshow here. Oop.
Yeah, we talked about the UK variant. I don't think we talked about the South Africa variant.
We stopped at the South Africa. I think you're right. So here is the South African variant. So the UK variant has 17 mutations, and its particularly strong mutation is a deletion mutation that allows it, and that seems to confer a much more rapid capability to transmit, about a 70% higher capability to transmit. Overall, the R value will probably go up by about 56%, which is a big jump and that jump, of course, affects our requirement to get to herd immunity, as we talked about last time, because the formula for herd immunity is 1 over 1 minus R0. So if you start to increase that R0 by a lot, all of a sudden you're subtracting by a smaller and smaller, fraction, which makes it get bigger and bigger when you go 1 over that number, right? So all of a sudden we're talking about, before we were talking about, it would be great if we can get, theoretically that formula indicates that we need to get to a herd immunity of 54%. If you think that the R0 is 2.37. Now we know that in real life, because we don't have a perfect grid and they're isolated communities where you've got a lot of people who are still unvaccinated, we know we have to get closer to 75%, 70%, 80%. I always thought the right number was 82%. And the reason I thought this was because of real life. In the amount of protection they've got in Taiwan is 82%. And that is as a country that is back to quote unquote normal because of traditional mask wearing. So if we think that 82% was enough before, that pushes us to about 90 to 91% requirements for full herd immunity, which means you can walk around and everything's back to normal again, because there's enough people who have vaccines that are effective enough that the people who aren't vaccinated are still protected because the virus can't find you in the herd. That's what we talk about, herd immunity. So that number becomes really important, that R number, and we think we're going to have to increase from 82% or so, from 80% vaccinations to 90% vaccinations. And that's a number that's almost impossible to get to. And we should talk a little bit about that a little bit later. I'll tell you why. So now we have these issues of variants. And the first variant we talked about was the British variant, and it allows you to, as I said, reproduce a lot faster, which allows more genes to get in the gene pool, which allows more mutations to occur, which then allows more stacking of the genes to occur, which allows for more and more effective viruses that are going to try to escape our drugs. That is a cycle that continues as we get more and more people infected. And what we're worried about is eventually finding a mutation in the virus that escapes all of our vaccines and all of our medicines. And we mapped out about 4,000 mutations that we were worried about. And there were kind of 20 or 30 that we were really worried about. And unfortunately, 3 of them exist in the South African variant. And you'll see the result in a second. So I talked about the fact that it was very important to start to test much more effectively, not just whether you're sick or not just whether you've had the virus or not, but what virus you actually had. And the way we do this is with actually genetic sequencing. We actually sequence the whole genetic code of the virus, like you would in a crime scene. We say, this one is this variant. And we don't do this very much. We do about 0.3% of all the positive tests we get are actually genetically sequenced. And that compares to Australia that does this about 60% of the time, 200 times more than we do. Or UK, they do it about 7.5% of the time. South Africa is similar to us. They also do about half of a percent or so of their, so it's a little bit better than us, of all their positive results, then go and get genetically sequenced. And you can see here what happens. What happens is, here's the white lines. That's the virus. That's the major virus. The majority of the virus was something other than the virus we see today. And you can see that there's a new blue virus that's sort of coming in and kind of getting to become more important. And then suddenly on October 5th or so, we saw the first little yellow line, right? 1% of the total viruses that were out there infecting people. Well, 2 weeks later, it was about 10%. And 3 weeks later, it was 80%. And that's what happens, right? You go from 2 to 4 to 8, 16 to, and so if you're not testing fast enough, you will miss the exponential rise of the importance of the virus. And you can see that today it's over 90% of what's happening in South Africa. And concomitantly, we see the death rates, right? Here was the European, here's what on the red indicates happening in the UK, and they have that funny virus, the B117 virus variant, and that reproduces fast. And so it's causing, you can see that they tried to shut things in, right? So here they came down, everything's great, September, October. November 15th, Boris Johnson got up and said, we are having troubles on this curve. You see this curve right here? From September to November, we're starting to double, we're starting exponential growth. Everyone, I want you to lock down. And they went into a big lockdown. We're talking about, after 8 o'clock in the evening, you couldn't go out on the streets, you couldn't go shopping, you couldn't walk your dog, you couldn't do exercise. I mean, we're talking, much more severe lockdowns in the major metro areas. And you can see they had some success, right? November 16th, things were going up, and then they peaked and they came down. They said, we're back in control again. Isn't that great? All of a sudden, December came and they went off the charts. You see how that worked? And that was the new variant that reproduced so much faster. And the reason that's so worrisome is it means that our traditional ways of masking and everything else that we're doing that we use to control the virus today aren't going to work with the new variant. You're not going to be able to use the cotton mask. We're going to have to use real N95 masks. We're not going to be able to stay in the, in Walmart anymore for 2 hours like we do and walk. And if it's pretty safe at 7 o'clock in the morning, better not do that. Better, if you're not really being 6 feet away from people when you're in line checkout, you're going to get sick. That's what this means. Is that the old ways we're working, our old behaviors that we think, I can do that. I've done that before, aren't going to work. And that's what caught all the Englanders by surprise today. Everyone's in full lockdown, even if you're way up in the countryside, and we're seeing it go off the page. Now, the other variant we're worried about is South Africa. So here we see that's the green line, right? That's the official South African death rate. That's the official one. And now if we look at the next page, what's interesting about South Africa is here's the official death rate. That's on the right-hand side. Left-hand side. But what epidemiologists look at isn't the official death rate. They actually look at excess deaths. And the reason we do that is because sometimes you don't know what's actually hitting you. All you know is you're having an awful big spike in deaths. And sometimes there's, that must have been malaria. Oh, that must have been a cold. He got pneumonia, just died. He died of old age. So we don't really notice unless it's officially, he was tested, he had COVID, and sure enough, he died, and therefore it's a COVID official death. Well, the official deaths you can see were around 600 a day. The total deaths, post-mortem deaths that they think they had were about 4,000 a day, but the excess deaths they're having is about 20,000 deaths a day.
20,000 a day?
Yeah.
In a country of how many million?
Oh gosh, I think it's about, I don't know, it's about 20, 30 million. Yeah.
No, I think it's more than that. It might be
50, 60. I have to look it up. I'm not sure.
Yeah. But in any case, that's an astounding number.
Isn't it? Isn't that worry? I mean, so that's the difference in the official death rates over here on the black. The total deaths, post-mortem analysis and everything they could come up with, at the morgue was about, 4,000. The real number is actually probably 5 times that. And
yeah, you were right about the population. By the way, it's 59 million.
60 million. Yeah. Okay.
Yeah,
thank you.
South Africa.
South Africa. Yeah, 60 million. So
20,000 a day with 60 million. That no matter how you cut it, that's amazing.
That would. I was going to say that would be like 6 times 5. That.
Be like 100,000 a day.
Yeah, that would be 100,000 or 120,000 a day here. Wow.
Yeah.
Yeah. So that's why they're so worried, right? All of a sudden they got this new variant. They know it's a new variant. They actually tested, they found it. And you can see it's just off the charts as far as deadly goes. And that's the total excess deaths. And that's what we really worry about as epidemiologists, because that's the only new thing we really have in South Africa. And you look at last year, they didn't have COVID in place. And that's the excess, that's how far you're coming off that curve. And we usually give it about 3-4% of variation within that, because every year is a little bit different. We have a little bit worse flu season and so on. So that's why we're so worried about the South African variant. And here's what Moderna announced today, right? They announced today we're going to have to go back now, and we're going to have to go do some phase 1 work. We know what the variant is. We're going to go ahead and do the following. We're going to go ahead and we're going to we sequence this, right? That's day 1, and now we're going to have to engineer it all, put it back in the plasma. We got this little drill bit system. We've got the platform. We put the new drill bit in. Now we can drill a slightly different hole, right? And it's not going to be the same hole as we use for what they call the G variant of the virus. That's the one that's infecting everyone around here generally. It is a drill bit and a vaccine for something new. So 40 days later, they're going to have a shipment to the clinic, and they're going to go through the phasing that we talked about and phase 1 results. And they're hoping that after phase 1 results, so after about 3-4 months, right? They synthesize this after about a month and a half, and they've been watching it for some time. And that now they're scaling it up, and they're hoping that after about 2 or 3 months, they're going to be able to go and say, we've got this new data that indicates we're neutralizing, that this new vaccine neutralizes this virus. if the FDA says, yes, we agree that all you've done is really change the antigen in your shot, you don't have to go through all the efficacy testing. All we have to do is bridge slightly, show that they're still pretty safe, show the same safety results in a few patients, and you're done. That'd be about a 6-month process to get a brand new vaccine. If the FDA says after phase 1, neutralization is enough for us, they're talking about a 4-month process. But it takes some time once these new variants are out there to actually get a vaccine for it, that we think we can move into the regulatory component of the equation. So here was this is Pfizer and Moderna. And you can see with Moderna, that's an orange, that they had very good circulating antibodies. That's the antibodies that attach the virus and attack it before it even gets into your cells, and very good persistent immunity also. You can see that they actually increased the titers here. They neutralized versus convalescent plasma and single dose levels. They're 50 to 80% higher. Unfortunately, for the older people in Moderna vaccine, I'm always a little bit concerned, frankly, about the older people in Moderna vaccine because of this phase 1 result. This is based on the result of about 45 patients, so not a very big study, but you can see that you can actually start to see whether your immune system is kicked in or not. That's the purpose of the phase 1 study. It doesn't actually inject people and let you walk around and get sick. It actually just looks and sees whether you got neutralizing antibodies. So let's take a look at it a little bit closer. This is the actual results that they reported to the FDA. I just wanted to show you how tight this looks. 6 times sounds like it's bad, but if you actually look on the log, now it's a little bit confusing, so I just want you to take a deep breath. Now on the top, we see these are the circulating antibodies. Those are the antibodies that are against the spike proteins and the receptor binding protein. And on the bottom, C and D, those are the neutralizing antibodies that I showed you before. So you can see after 1 dose versus convalescent plasma that we're at about the same level as 1 dose for your circulating antibodies as with convalescent plasma. When you take that 2nd dose, you get 10 times that, and that's why we saw that big jump. Again, it's a logarithmic scale here that we epidemiologists use logarithmic scales. Otherwise, if we had to do it linearly, this chart would be off the page, right? So we try to condense it, but it's harder to read. So just to get used to that every one of those, it goes 10, 100, 1,000, 10,000, 100,000, a million, and so on that scale. And unfortunately, these are log 2 scale on the actual neutralizing antibodies. Again, you can see though that basically after 1 dose, the neutralizing antibodies are slightly lower than convalescent plasma, and that after the 2nd dose, you're significantly above convalescent plasma, right? And the same thing's true about the PRNT. This is a much longer test. It actually is the gold standard test. And you can see here, again, that we are above the convalescent plasma levels. So that's what a 6-fold reduction will do for you. It still means we have a pretty good vaccine against this South African variant, we think. But we also think that boosters might be likely, especially for the elderly population. And we may have to create a new generation of vaccines every year or every couple of years, like we do for the flu as these variants build. Here are the actual titer levels. So I graphed them against the original. Here's what they are actually in. This is what was just reported now about 2 hours ago. So you can see, so everyone's watching this very carefully. We're all very worried about this. So we're all talking among each other, trying to figure out what this all means. So you can see here's the log level again. You can see this is the 6-fold reduction, right? You see, the log scale 3, 4 versus a log scale of 2 on the reciprocals, and you can see the drop in the titer levels 6.4 times, and the p-value incredibly high. This is not a random event. This is statistically extremely significant. The chances of this happening randomly are about 1 in 1,000. So it's a really significant event, and that 6.4 times reduction is a really big shift. The G on the baseline, that's what we all are worried about in the United States. That's our predominant virus. The B1351, that's the South African variant. So you can get a sense of just how much more in this graph here. What we're interested in is how much more of the antigen do I need in order to neutralize this virus. It's about 10 to 100 times. It's well over 10 times more circulating antigen I need. in order to neutralize. Luckily, we do have that in the vaccine right now, but if you add a couple more mutations, what was interesting is you can see the difference that a few mutations. We were most worried about the that green line. Those are the predominant mutations we're worried about. We're worried about 3 mutations that are occurring right at the binding site for the ACE2 inhibitor of your cells. And that it confers a much stronger affinity, binding affinity, as a result of these mutations. And so the green line is what we were worried about. Those are the 3 predominant mutations. The blue line is you add those 3 mutations plus the extra 21 additional mutations, all of a sudden it gets even better at avoiding being neutralized by our antibodies.
Hmm.
And that's what we're worried about, that shift in the line from the black line and the red line over to the blue line. It's a 100-fold shift. And that's a big shift to require how much more circulating antibodies, more neutralizing antibodies you need in your body in order to kill it. So even a small reduction in duration of the vaccine is going to mean a big shift in how much you're able to kill off this virus, whether you be protected or not, if that makes sense. The red line is sort of interesting. That is the line for the British virus, which we are now finding in the United States. I don't know if you saw, but University of Michigan announced that 6 of their athletes had come down with the B117 virus variant. And so they've actually shut down all of their athletic events for the next 2 weeks because they're so worried about it running through the campus. Right now we're in the middle of rush at University of Michigan.
Oh, geez.
So, yeah, what could go wrong? I mean, it's an incredibly infectious virus going right through the sporting
during the heart of kegger season. Yeah.
during the heart of yeah, exactly. So
Good
that's
grief.
some of the things that we're worried about with this virus, and so I wanted to show you that quickly. And as I said, because of this, we're gonna have to test a lot more. We're gonna have to find out and be a lot more aware of which virus we're dealing with and whether or not we have to have different vaccine for that, whether our tests are even picking it up. And one of the things that worried me today is that we actually made the Wall Street Journal today because they talked about about counties that were underrepresented in terms of their testing. And this is Wayne County. This made the Wall Street Journal today. And you can see that the little black circles are what we're interested in. That is where our rapid test sites are, right? And if you look at where the poorest populations are and the people who are most likely to be affected by COVID, and the people who are least likely to be able to take off work for 14 days because they think they might have it, and the people who are out there probably being more represented as your essential workers, those are the guys who don't have access. So if we're wealthy, if we're wealthy on the border of Oakland County, we can get it. We've got lots of sites to choose from. But if you're in the middle of Detroit, you got to walk, or you got to get on public transportation, do something for about a 10-mile radius in the poorest areas of Detroit. And those are the people who are least likely to be able to, sadly, isolate themselves and take time off of work. So that's a challenge, and we need to solve it pretty quick because now we're going to have to test a lot more and be a lot more professional about it. So, so the thing we're worried about most is getting to herd immunity. So I wanted to show you some things about herd immunity that are a little bit worrisome, but worth talking about. And that is that we are pretty darn close to being on the fringe of herd immunity. I talked to the fact that we think that the vast majority of our people of the things that we're going to have to fight are going to be the B117 variant. And that's because it spreads so fast. Now, the problem with that is that we think that we are going to, we have a special formula for herd immunity. And it's the vaccine effectiveness of stopping a transmission, or your immune system, times the percent of the population inoculated, plus the recovered population, because they're going to have some protections. We think it's about 52%. The people are 52% protected for about 8 months. So if you've had the virus, you're probably 50% protected for about 8 months. That compares to having a vaccine and being 95% effective, effective immune system for a longer duration than 8 months. We don't know how much longer, but like longer. So if you've had the virus and think you're protected, still get the vaccine if you're eligible and can get it, because it's going to protect you that much more. So we know that, as I said, with the variant, we probably went from about needing to vaccinate 80%, 85, 82% is what the number I use, 82% of our population, which is about 330 million people. That's 280 million people. But if we now have this new variant, we think we may have to get up to as much as 300 million Americans being vaccinated. And not just vaccinated once, vaccinated twice for the 2 vaccines we've got. If J&J kicks in, then it's only once. But that's a pretty complicated formula to get that many people vaccinated as fast as we're doing it. And we'll talk a little bit maybe next time about all the challenges we've got. I think we talked about the distribution challenges last time.
Right.
So now we talked about manufacturing. We talked about the fact that distribution is tough. And now we're going to talk a little bit about what happens if people don't want to take it.
We're going to have to save that for next week because we're almost out of time.
Oh, you're kidding. So I just wanted to say that gosh, this goes quickly. So at any rate, so here's the quick answer for next week is we are really tight on how many people can actually say, I don't want the vaccine, thank you very much. And our ability to get herd immunity. And with that, why don't we hold off and we'll talk about some of the things we can do about that next week, because there's some really interesting things that we can do about that. So
lastly, before we wrap, let me just ask you, as you know, we got a new president last week, and we talked about this. In the light of all this, do you think he's be able to get 100 million vaccinations done in 100 days?
If he does that, yes. The straight answer is yes, but I don't think that's going to be sufficient. I'd like to see us be able to vaccinate about 2% of the population per day. That will be a balance between how much supply we'll have based on what the manufacturer's saying and how much demand we'll have. We have to get to a point of being able to vaccinate 2% population a day. And what he's recommending is, I think, about 0.6% of the population a day. And that's insufficient if you really want to go as fast as I think we're going to need to block these variants.
Traditional four-year students love Lawrence Technological University's thriving campus life. But LTU has always met non-traditional students' needs too. Lawrence Tech offers over 100 degree and certificate programs that can get adult students started or back on track. And most of our classes are conveniently offered evenings at our beautiful Southfield campus or online, so you can balance your social, family, and work life even while you power up your career. Lawrence Tech, where Blue Devils dare.